you click on the link to get our newsletter. That's something that goes out periodically, and it's just a way of, from a manufacturing standpoint, to be able to communicate to our customers and our contractors what we're doing up here. So with that all said, today's topic is high capacity and deep set submersible pumps. Now these are 4-inch submersible pumps that we're going to be discussing today. However, these two categories are they're special categories within 4-inch submersible pumps. Special in as much as we actually have a dedicated line back in our factory, dedicated just for the manufacturing of these two types of pumps, these high caps and deep sets. So, if you ever get a chance to come up here this fall or winter, you'll get to see that firsthand. I'll maybe talk a little bit more about that by the time we're done with this presentation. But that said, we're going to start off talking about the high capacity pumps, all right, the high cap pumps. When we look at these high cap pumps, again, they're 4-inch submersibles, and these pumps are going to be used in applications where traditional flow rates, where they're going to need higher flow rates than perhaps a traditional, half horsepower or 3/4 horsepower, 10-gallon a minute pump can deliver. So that said, the applications for these high caps, I've got a few images up on the screen there. There's a lot of applications where it's both the home and a fairly sizable irrigation system all combined together. So that would be an application where you would need higher flow rates, higher pressures. These pumps are also used to irrigate sporting fields, football fields, baseball fields, and so on and so forth. They're used quite frequently for that. Livestock watering, I should bring these up, sorry. Livestock watering, that's another application for these high cap submersible pumps. And again, the emphasis here is going to be where there's a demand for flow rate, gallons per minute, that's higher than traditional residential type submersibles. These concrete underground cisterns, I've seen high caps used a lot in these applications. They'll shroud that motor and they'll put that down into a cistern, and they'll collect rainwater into that cistern, and they'll pump out of there with a high cap pump, and they'll be able to, again, irrigates whatever that application may be. So irrigation is quite a big application for these high cap pumps. Now, when we look at these, all right, that's a couple things that make this different from your traditional or your residential submersible. These, first of all, they have a 2-inch discharge, all right? I'm going to try to show that there. There's a 2-inch discharge. I don't know if you can see this very well on the screen, but also notice there is no check valve. I'm going to circle back on that. But these high cap submersible pumps with the 2-inch discharge, they do not, like all the other residential subs, they do not have a built-in check valve, all right? So that's going to be up to you, the installer, to put that check valve in the line somewhere. As you can see, these will throw a fairly decent amount of water. We have 3 series, 35-gallon a minute, 55-gallon a minute, and 85-gallon a minute. That's the 3 series that these high cap pumps are available in. And the 35-gallon a minute is going to start off at a 1 horsepower, and the 55s at 1.5 horses, and the 85s at 2 horse. All of them, on the other hand, will run through 7.5 horsepower. So that's your selection when it comes to these high caps, all right? So you've got quite a selection there. Additionally, you can choose between stainless steel and cast iron. So, the cast iron are very popular in markets. If you look at the cast iron discharge, for example, this is a cast iron discharge here. That cast iron is so robust. Will it ever, rust through? Yeah, it will. I don't know that we'll live long enough to see that happen, but eventually it would. But the life is going to be quite long on that, so they're very popular. On that cast iron pump, the only thing on there, cast iron, will be that discharge, and then the motor mount that's going to mount that wet into the motor. That's going to be a cast iron motor mount wrapped with a stainless steel suction screen, whereas the stainless steel, top to bottom, right? Stainless steel all the way down. But those are your choices when it comes to high cap pumps as far as the family of product goes. So it's a fairly broad line there. A couple of things that I want to point out about this high cap. All right, now I think most of us could agree. And when I talk about traditional submersibles, you know, I'm talking about these fractional horsepowers. Other markets, you know, maybe a 1-horse 19 if they've got a little irrigation going on, something like that. Those are all inch and a quarter discharges, and they all have check valves in them. They all have. On the other hand, the 2-inch discharge, as you can see on the screen, that there's no check valve in there, but I do want to point out a couple of features here, because high cap pumps and deep set pumps, both, they are not typically going to be field scrapped like you would a residential submersible pump. These pumps, on the other hand, you know, if they can be fixed, and when I say fixed or repaired, typically that's going to be either replacing the pump end as a complete wet end or replacing the motor. That's still done on these two categories of pumps. That repair is still made. And that said, I want you to see a few things that are in this pump that I think kind of makes it stand out. First of all, at the top is what's called a discharge bearing. All right, I don't know that you can see that here on this submersible here. Renee's giving us a little hand there, but you can see that discharge bearing up there in that housing up there. All right, way up here at the top, right there, that discharge bearing. Now, what I want to point out here with respect to that discharge bearing, thanks Renee, is that it is a no lead closed bronze discharge bearing. All right, it's a no lead closed bronze discharge bearing. That means that the pump shaft is going to come right up into that closed bronze bearing. Now, if you're not using a closed bearing like what we've just shown, then you are going to be using a sleeve bearing, right? And that sleeve bearing is pictured over there on the right-hand side. In fact, the industry as a whole, very big on sleeve-type bearings, as you can see up there at that top right. Now, the reason we use a closed bearing, all right, there are certain markets where certain geographic areas where if you drill a well, your likelihood of having sand is pretty high, you know, pretty high. And there's some places where it is almost always the case. And sometimes I've heard contractors refer to sand as, they call it sugar sand. I've heard them refer to it that way. And if you ask them why they call it that, they say, well, it's so fine. It's really, really fine. And so, you know, it doesn't plug the aerator up in the faucets and so on and so forth. But let's look at this slide up here. See, our engineering staff here at Flint & Walling, they do not believe, and I think rightfully so, that a sleeve bearing is watertight. Water has the ability to pass in between that bearing and the pump shaft. All right, it's not a watertight pathway there. So, if in fact you do have a sand-bearing water supply, and worse yet, it's the sugar sand. It's the fine stuff that a lot of people don't really pay much attention to. But you start running sand between that bearing and that shaft, and you prematurely wear that bearing out, I'm telling you, that pump's going down, and not maybe, that pump is going to fail. And that's what's going to happen there, just by running, you know, garbage up between that shaft and that bearing there. So we opted to go with the closed bearing. Why? Well, there is no pathway there, right? Water can't pass through that bearing along that shaft. And so that's one of the reasons why we use a closed bearing at the top of this discharge, right? Something else I was thinking I wanted to tell you here. I'll move on. The bearings at the top are sleeves. There is one down to lower right. That's a closed bearing. There's an outfit that uses that. It's not us, but it's a closed bearing. And none of those will take much heat. That bronze bearing, that'll take a lot of heat. So now when we talk about this discharge, you know, we're going to move down into the pump itself, but when we talk about the discharge on a high cap pump, these are a couple things that I've pulled out of the instruction manual I think is important to know. One, when you install a high cap pump, any pump for that matter, any submersible pump, we need to understand that we should install it with the same diameter pipe as the discharge. So a 2-inch discharge high cap would have 2-inch piping on it. If you do not use that 2-inch piping, and you go down to that note below and you start to reduce that pipe size coming out of that pump, expect your performance to also be reduced, all right? And that's what's going to happen when we start reducing these pipe sizes down. If you do it, it's going to reduce the overall performance of that pump, all right? Now, when it comes to check valves, these are another a couple points that I pulled out of the instruction manual because I think these things they're referenced. I hear contractors reference to this all the time. And by the way, these same points are in everybody's instruction manuals that I've looked at, every other brand. But since there is no check valve on a high cap pump, the instruction manual is going to suggest that a check valve be installed within 25 feet of that pump. So up that discharge pipe, the water is going to be running a lot more linear up there than it is right out that discharge. It comes right out of that discharge, and that water's spinning at the rate the motor's turning. And so when you get up that drop pipe, you know, up there, what they're asking for is 25 feet, then that water is going to run linear at that point, or laminar. For well depths that are over 200 feet, their recommendation is pretty strong that additional check valves be installed, all right? Because we need these check valves to hold that water in that piping. And the more piping you got, you know, the more water you're going to have to hold. And so oftentimes additional check valves are used for that purpose. And again, that's for depths over 200 feet. And we're going to also suggest that you add one up there at the tank, between the tank and the pump, on a horizontal run. You do that, you have check valves on these systems. You don't have to worry about these pumps having check valve failures and water running backwards. So that's a couple things on the check valve. When we look at the impeller, all right, the impeller design is very, very similar to the impeller designs that we use in all of our submersibles. And the first thing I'd start off by saying is that the tolerances aren't very tight. And they're by design, we don't want them tight. We just talked about sand a minute ago. And if you start tightening impellers down to where your tolerances, you got really tight tolerances, you're going to sandlock the thing. You'll sandlock it and end up probably eroding material off the impeller as that sand goes through. All of our impellers are balanced so that no vibration. Our impellers and diffusers, you can see those over there in the red box on the right-hand side of that screen. Those are dissimilar materials. They're Norel and acetal, but they're not the same type of plastic. And some companies, they put everything in that pump end is all made out of the same plastic. And let me tell you something. You get heat rise. When you get heat rise and everything's made out of the same ingredients, it all melts down. It just becomes one big glob inside that pump end when you get a heat rise going on. So we use dissimilar plastics, and especially if you got plastic rubbing against plastic, you don't want to spin weld them together. And then probably I think one of the best features of a Flint & Walling sub, whether it is a high cap, a deep set, or any other sub for that matter, is a floating stack. Flint & Walling, by design, will float that impeller inside that diffuser. And if we build that pump properly, and we make every effort to do that, but when we do build that pump properly, that impeller, when that pump is up and running and under a load, that impeller is designed to float in that diffuser, all right? So that thrust washer you see up there at the top, that stainless steel thrust ring, there's where these are, that's not even in play. That's not even in play when you're floating the impeller. Neither is the bottom portion of that impeller. And so when you're floating an impeller, just think of this. How much wear are you going to get? How much wear are you going to get when you're actually floating inside, all right? So when there's no rub at all, you get longevity out of that thing. All right, moving along here, those stainless steel thrust washers, again, we stamp those out here. Everything that is in that thing is fabricated and manufactured here. So the stainless steel thrust washers. Not everybody uses stainless steel. Why would we want to use stainless steel? I'll tell you why. Because every single pump is going to be in an upthrust condition. Every brand is going to be in an upthrust condition, especially when you drop that pump down that pipe, that well, for the first time, or if you're just replacing a pump, or you took one out to service it. Nonetheless, you're putting a submersible back down in the well. Imagine this. The only water inside of that drop pipe coming out of that pump is wherever the static water level is inside that well. Think of it as putting a straw down in a glass. The water level inside that straw is going to be equal to the water level in the glass. And so think of it that way. Everything above that is empty. That pipe's empty, that pressure tank that's up above, that's all empty. And so when you power that pump up for the very first time, I'm here to tell you, all those impellers, all those diffusers, they want to just come screaming out that discharge right along with the water. That's called upthrust. And so it's that condition that we want to make sure that we protect those impellers and diffusers because we're not sure how long we're going to be in that condition. That's one way that you can get into upthrust. But, you know, I've seen drillers, when they drill wells, one of the things that they'll do afterwards is they'll develop that well, and that's done differently in different parts of the country. Here in Indiana, a lot of times they use compressed air. They'll pump air down that well and bring that up over the top. But in other places, they'll just pump that water, open discharge, like you see on that picture. And they'll run that water out there until that water clears up. So they're pumping out all that drilling fluid and the mud and the shavings, all that crap's going out that water line until that clears up. Well, how long is that going to be? I don't know. It could be a couple hours. Well, then a couple hours you're in upthrust. It's pretty important that you have a bearing or a washer system in place that's going to withstand that kind of condition. The other thing I want to point out here on these high cap pumps, and I'll be pointing this out on our next segment with the deep sets, is the amount of staging. All right, the amount of staging. We don't keep that a secret. So many pumps and so many manufacturers over the last several decades seem to be on a gambit to destage pumps for whatever reason. But we've never done that here. You can see that 35 gallon a minute, and that will go from 4 stages on a 1 horse up to 23 stages on the 7.5. And you can see those stages on the 55 and the 85 as well. All right, and that staging will equate to performance. When you look at a Flint and Walling pump curve, and I would encourage that you do that. If you haven't done that in a while, look at some pump curves. And in fact, take it a step further. Compare them. Compare pump curves across the brands. Because what you're going to find is that we've never destaged these pumps, and so our pump curves are going to be relatively steep when compared with our peer group. They tend to flatten out where we will maintain a fairly steep pump curve, meaning as you move left and you have more head to deal with, we're still giving you a fair amount of water over there. So high performance on these high caps have made them very, very popular in markets. We're going to move now to another pump, which is referred to as the deep set. And I know this may sound a little salesy, and I don't mean it to, but it's a fact. That pump in deep set markets can just absolutely dominate. And I know for a fact there are drillers out there. They may sell another brand of pump day in and day out for their everyday type of applications. But when they have a well that is deep, they'll look at that distributor salesman and say, I want you to bring me an F&W out there for that job. I'm going to put that down in that well. And the reason they do that is they know that it stays in the hole. All right, it stays in the hole. But when we talk about deep set pumps, all right, not every geographic market's going to have an application for deep set pumps. Here in northeast Indiana, where we all reside, we don't sell any deep set pumps up here because we have no terrain change. We are very, very flat. But when you get into areas of this country that does have a lot of terrain changes, you got houses that sits up on top of these hills. You ask them how deep their well, how far does the well go down? Well, that can be sometimes, over 900 feet or 1,000 feet or more. That's what's referred to as a deep set application. And that, just by its very name, it's a deep set. And these deep set pumps. So again, let's just look at this. The little blue area down at the bottom would represent an aquifer, all right? An aquifer, and that's a terrain change, that brown area going up there. But if you have a house at the very top of that hill, and that's what we're talking about when we're talking about areas where they have terrain changes, that well is got to go all the way down to that aquifer. And so these deep set pumps, as you can see, they can handle these heads up to 1,500 feet, all right, up to 1,500 feet. So if you have a well that's, you're setting a pump, let's say you're setting a pump 800-900 feet down a well, all right? how much pressure is that pump going to have to produce just to bring that water to the surface? Much less have pressure left over so that we have usable pressure to operate a home or an irrigation system or whatever that application may be. It takes a lot of impellers, all right? So when we look at these deep set pumps, and when I say impellers, you know, one thing that holds true with submersible pumps as a general rule, the more impellers that a submersible pump will have in its wet end, the more impellers, the more pressure that pump will produce, all right? So these deep set pumps are going to have a lot of impellers in them. But these are your family of deep sets, all right? You've got a 5, a 7, 10, a 19, and a 27 gallon per minute series, all right? So that's able to take care of homes and homes with irrigation for the most part. From a horsepower standpoint, they're going to start off at 2, and they'll also run through 7.5 horsepower. Now, deep set pumps. I mentioned when we started on this that these two categories are pumps that are typically repaired. We have a lot of orders come in for deep set pumps, and the only thing that the customer's wanting is the pump end. They have a motor, and perhaps the motor's good. So we'll build the pump end for them. But I want you to know this, that even though you order a pump end from Flint & Walling, a deep set pump end, before that leaves this building, that is going to get put on a motor just like the one you're going to put it on. And we're going to throw that down into a wet pit, and we're going to test that pump, and we're going to check the hydraulics and the motor both, and we've got a lot of parameters we're going to check in that process. But that's a 100% test that we will do every single time, whether it's a high cap, whether it's a deep set, ordered with or without a motor. Every single one of those pumps are going to be put down in a wet pit with a motor attached, and we're going to test that thoroughly. So when we talk about, and the reason these pumps, and I know this sounds salesy, but they do dominate. In markets where there's deep sets, these guys put Flint & Walling down. Why? Because they don't have to pull the pump out and work on it. Do you know how much it costs to have to pull a pump that's 900 feet deep? You aren't doing that by yourself. So it's very, very costly to have to pull a pump out of the well that's that far down, and they don't like doing that. And so therefore, that's why they're putting these F&Ws in. And when we look at that, we've got this check valve now is going into all these stainless steel 1.25" discharge pumps here, but you're going to still have additional check valves on that pump because of the length of piping that you're going to have. But that's a nice stainless steel check valve in the bottom of that. It withstands all that turbulence within that discharge. As I mentioned, that water spinning as it comes through there. That check valve has proven to be very, very successful since that's been launched. The other thing, you'll see that closed bearing just below there, right? And we talked about this with the high caps, but you'll see that closed discharge bearing. That's going to withstand heat and debris. And again, when we talk about that, there's the heat, okay? So this was actually a 4-hour run dry test that we did. We do a lot of destructive tests here at Flint & Walling, and not only do we do those tests on our pumps, but we'll do them on our competitors as well. But that's a 4-hour run dry. And you can see there was no destruction to that bearing whatsoever. I'm going to tell you something. The sleeve bearings, if they didn't melt, they fractured. They cracked. If it was ceramic, it's going to split because it can't take temperature change. It's a great material, smooth, great sealing surface, but ceramic does not like temperature changes. So therefore, I think that in those kind of conditions, whether it's a deadhead or a run dry or whatever that may be, you get into heat rise, this pump's going to withstand it. All right, this pump's going to withstand it. And that floating impeller, that's going to also be a big, big feature, especially on a deep set pump where you can have, I'm going to show you here in a second, how many impellers you can get put in some of these deep set pumps. Those pumps that you're looking at over there on that right-hand side, that is just the pump end, okay? You go all the way down to the bottom, that's the suction screen. So these can get these can be 5-6 feet tall, just the pump end themselves. But that impeller is what makes that F&W pump stay in the hole. That's what makes it last so long, is that we are literally floating those impellers. And here is a copy right out of the catalogs. I want to talk to you about the number of stages. So let's look at this just quickly. At the top is a 2 horsepower, all right? 2 horsepower deep set. It's 5 gallon a minute. It's rated at 5 gallon a minute. That's going to have 42 stages in it, 42 impellers. Drop all the way down to the 7.5 horsepower. Or no, just go down to the next one, that 3 horsepower. That's a 5 gallon a minute. 60 impellers, all right? So you can see with these deep set pumps, there's going to be a lot of impellers in these pumps. And if you can float every single one of those impellers, and you can float them, and we do that very successfully, then you get longevity in life. So I guess we're coming down to my last couple slides. I'm not sure how we're doing on time. Well, we may get to about a half hour. The other thing to keep in mind on deep set pumps, and not just deep set, but especially deep sets, is these things called torque arresters, all right? If you've got a pump that's sitting down in a well, all right, whether it's a couple hundred feet or 800 or 900 feet that we're talking about, it's very important that that drop cable that goes down to that motor, that it does not rub against the inside walls of that well casing, or the piping for that matter. And the drop pipe that's used to hang submersible pumps varies from one geographic market to another. I mean, it's not always the same type of material used, but the important thing is that we don't want any of that pipe or cable rubbing against the inside walls of that casing. And I'm going to tell you something, every time these pumps start up, every time those motors start up, they're up to full RPMs in a blink of an eye. 0.4 of a second, that rascal's at full 3450 RPMs. And that causes a torque. Just like you hit that gas pedal in your engine, you get that torque, right? So what that torque does, it causes everything above it to spin. And if you've got cable over against the walls of that casing and it's rubbing against that every time that pump comes on, eventually you're going to rub that insulation thin, and that's going to short that pump out. So I've actually seen where it's rubbed plastic pipe where it rubbed the walls so thin it finally popped through. So these torque arresters, they'll go around the pipe, they'll go around the drop cable, and they'll clamp all that together so that it stays centered within that well. And sometimes, particularly on these deep sets, they may have 2. I've even seen 3 of these torque arresters. You know, every couple hundred feet they'll put a torque arrestor in just to keep everything centered there. Anyway, that's the high caps and the deep sets. I think that was my last slide. I wanted to just end this session today with an invitation. Over the fall, winter months, we're going to have a lot of people come up here and take a factory tour. If you've never taken a Flint & Walling factory tour, I'm going to tell you something. It will be an experience like you've never had at any other pump company for a few reasons. One, you're going to come into a building that's 159 years old. The shell of this is very, very vintage. What's inside is absolutely cutting-edge, state-of-the-art. And when contractors and distributors come to Flint & Walling to take a tour, they not only get to see all these pumps manufactured, but you're going to get to see motors manufactured as well. And that's what's going to make this an experience unlike you would have anywhere else. That all said, I think we're done for the day. Appreciate you being with us. And again, hit those like buttons and subscribe and hit that bell, because we'll be doing these coming up here pretty quick. Anyway, I think I drugged that to about 30 minutes. So thank you very much. See you next time.